Hello and welcome back to my channel. So last week we introduced the upper intermediate part of data structures. So we have our binary trees, we have our linked lists, our stacks and our queues. And for those of you who are new here, this is Java with Ali and I am Ali. Thank you to all the subscribers so far. I'll continue to make them. Please also comment below if you want to cover specific topics or anything like that, or if you have any questions. Okay, so let's get started. We're going to talk about linked lists in a little bit more detail. It's going to be a short video. I just want to give you as much information as possible, but in shorter videos because there's a lot to cover. So with linked lists then, because we want to cover certain topics, so we have linked list is a linear selection. So we have a sequence and we use what's called a self-referential class. And I'm going to go through some of the code in here and demonstrate it. Now, I'm a little bit hesitant to use the word but it might be easier to understand because this is how my brain works and I like to link other topics to the same topics. So if you keep in mind the concept of regression in your mind first, then that might help with understanding self-referential class objects. So with a linear collection, they are built with nodes, so connected by reference links, and we access each of the reference links by the first node. And then the last one is always null. So the last node in any data structure should be null. That indicates the end of a list. So each subsequent node then uses a link, hence why it's called a linked list. That's my only joke for this video. And it's stored in the previous node. So the last node is null, which we know already. It's going to be the end of the list. And they're stored in and removed dynamically. And what does that mean for memory? Because we will run out of memory when we have an exponential amount of linked lists in our data structure. So, and also if you're in work and you use like a virtual machine or anything, it usually allocates less than the memory that you actually need to it because we're sharing memory across all of these multiple applications. It's not just for your program. Sorry to disappoint you, but it's not just for your program. So you have to factor in the memory allocation when you're doing a linked lists because it will run out of memory. It will throw an out of memory exception error. Why aren't we using things like arrays? Well, they can't be changed in size once you declare them. So if you're unsure about arrays, please check out that video. Why are we using array lists then? Well, we've got linked lists are the number of elements to be represented in the data structure is unpredictable. Array lists can grow and shrink as well. We'll get to this in a second. So as we go along, this is going to be part 1 of the linked list video, and we're going to dive into more detail as we're going along. But for now, just the most important things are talking about memory and performance. Existing elements do not need to be moved, but we need to know the insertion point. So with things like arrays, you need to move all of the elements as we go. With linked lists, they don't need to be moved. They can grow and shrink as well. Arrays can also be full. A linked list can be increase and decrease as necessary. Existing elements do not need to be moved. That's the most important thing. Then we get to self-referential classes, which we're going to have a look at here in our list node class, which we kind of looked at in the previous video. Well, not really, because I just basically showed it to you, but didn't go through the code. So here, if you're unsure about generic types, please check out that video. It was just in the previous topic. Which is really important because we're going to use a lot of them now. So we have what's called a self-referential class, and I'm hesitant to use this word, but it basically uses a similar way of regression. So we have here linked list node as the class name, but we also create a list node within the class. That's all. That is basically your self-referential class. You're making a new object from the object. That's basically what it is in very quick layman's terms. So it contains an instance variable that refers to another object. That refers to another object of the same class type. So you have a copy of it within the class object. So by convention, then null indicates the end of a data structure. Always keep this in mind because we come back to it time and time again. And we have two instance variables here. So we have next node, and we also have our data, which is of generic type. So when we instantiate a new list node, then E is going to be our generic type. So we don't know the list until we create it. So it links an object of type node E to another object of the same type. So it's required in order to obtain more memory space at the execution time and to hold new nodes and release space when needed. Java already has garbage collection. I also have a video on garbage collection if you want to check that out, but Java already has it. Yay! So you don't need to do things like release memory when you use things. So with the linear collection we have here, our list node, we're just going to have a look at this today. So we have our two variables here of data, which is of generic type E, and our next node. Then we have two constructors of list node, which take in a generic type as well. That generic type then references this, which is going to be our null, which is going to check the end of the data structure. And here then we have our variable 1, which is also generic type, and then we have list node variable 2, and we assign it to data, and then next node then which is our next object here. And then we also have our get data method and our get next method. So return this data and return this dot next node. Follow for part 2. I'm going to post it up next Sunday. It's really important because everything that I just slightly vaguely went through there is going to be referenced in list, and I'm going to post them up on my GitHub now so you can see, and I will start commenting on each line so you can see what it does and you can follow along. Linked lists, very important topic. So you need dynamic memory allocation, self-referential class. They are in a sequence. The end of a list is null, and they're in nodes, what's called nodes. You need to know the insertion point. You also need to know that they don't move. You don't need to move any of them, that you can just insert and delete. They can grow and shrink in size as you need. An out of memory error will occur when it runs out of memory. That's physical memory, or you can have a virtual machine set up and running your program because your computer program is sharing across multiple applications. Okay, so thank you for watching. A very short video today, but there's a lot of information in it to do with linked lists. And we'll come back to the topic next Sunday. Thank you so much for watching, and please subscribe to my channel. Tell all your friends. Okay, thanks, bye.